Hello and welcome back to our webinar on systematic test design with TESTONA. This is part 4 on test scripting using TESTONA. My name is Peter Kruse. I am the field application engineer for the TESTONA tool. We develop these tools at Assystem Germany and I am located here in Berlin. We've seen in the previous webinars that testing can be split in several phases. For each of these, we have a strong lineup of products from within Assystem. We've seen tools for test specification and preparation and test execution. In this series, we cover the TESTONA tool. As a starting point for this part 4, we will use the example we had in the previous webinars. We've seen this database example with several input values, and we've already learned that we can specify expected outcomes and test results. So taking this as a starting point, the question typically is, how can we now execute these test cases in our individual test environment? To put this a little bit more general, we have the situation that you use your specification to specify your classification trees. You might have functional requirements, you might have an agile board, and this ends up in a classification tree with a lot of test cases. And then you want to execute these test cases against your application running on Linux, Windows, or Mac OS. You might have mobile applications and apps you want to test, or you might have embedded systems and completely other systems you want to execute your test cases against. From TESTONA, we propose the usage of the generic code export. We've implemented a template-based export of test cases to JUnit, XML, or general text for almost all scriptable test execution environments. We'll have a look how this works. This is our starting point, the database classification tree. And we propose the annotation of code fragments or snippets to the individual test aspects. So let's see. For the database, we have this classification whether it is initially empty, average, or completely full. So we are going to model and implement these test cases for a JUnit environment. We assume that there is a set database method available in this, which supports, for example, the different values for databases. We will also remember the actual number of data sets within the database for later evaluation. For the user privileges, we have the normal user and the administrator user, and we assume that there's a set user method available, which then takes individual assignment, whether it is the normal user or the administrator. For the operation, there's a perform method, which takes the new, edit, or delete. This is all for the input values. For the output values, JUnit is using the technique of assertions, where a comparison is made, for example, whether the actual count equals, is less than, or is more than, for example, the old count. Here, this class element will then be replaced with corresponding comparators in terms of less, same, or more. Also, we have an assertion whether the whole test will be successful or not. So we can compare whether the actual success reported from the system equals to what we expect in terms of here success or failure. So the first step is to assign code fragments to all possible test parameters. In the next case, we have to specify some information how to translate the individual test cases, which we have in TESTONA, to test cases in the execution environment. And for JUnit, it happened that we have this public void test case name declaration you need to put in front of each test case, and the test case ends with this bracket below here. To have this executable in JUnit, you need some general declarations, like the import declarations of this assert framework. You need to have a class declaration. There might be a package declaration necessary, etc. So this is basically the information you need to translate TESTONA test cases into JUnit, which can then be executed in your development framework. Let's see how the output of this assignment looks. This is the output from the JUnit export here, and you can see it starts with the general declarations in the beginning. Then we have for each test case the public void test case name, and then it goes. We have the set database, which is set to full in the first test case. We store the number of data sets from the database in this variable. We set the user to the administrator, and then we perform the delete operation using Safari. We then check whether the number of data sets is smaller than before, because we are deleting something. We also assume that this whole thing is successful, that the test is executed successful. In the next step, this is test number 2, we have an average database. We store the number of data sets in the database. We set the user to administrator. We perform an edit operation, this time with the Internet Explorer. And then we check whether the number of data stays the same. And we also again check whether this is successful or not. And then this goes on with test case 3, 4, 5, and so on for all test cases. We've just seen that we can assign code fragments to the classification tree to enable TESTONA to export executable test scripts in JUnit. You might not use JUnit in your example, so let's check what else you could do. I've invented here my personal XML specification for test cases. Here I need to declare my database scheme to use, my database user, and the action to perform. In my syntax, we have this expect values notation. I want all my test cases to be surrounded with this test case declaration, and this whole thing should be a test specification. If I export this XML, I end up with this specification. Those of you already familiar with our example know that in the first test case we have the full database. We have the administrator which performs the delete operation. I call it action here in my XML syntax using the Safari tool. And I expect that the count, the number of values, is less than before. And I expect this value OK to be successful. In the second test case, I have the administrator with the average database editing things. The count stays the same, and I expect this to be successful. And in the third test case, and so on. So we've just seen that we could annotate, for example, XML fragments to the classification tree to export test cases from TESTONA to your individual XML syntax. In the first parts of this webinar, we learned that we can use the classification tree method to structure test goals. We used TESTONA to obtain test efforts. In the third part, we saw how we could annotate the expected results to the classification tree. And today we saw how we could generate executable test scripts directly from classification trees. Thank you for joining today's webinar. For further information, evaluation possibilities, and download of TESTONA, please visit our website. You can also contact us via email.